today's video, I'm going to see if I can turn Gimli's walking axe from Lord of the Rings into a functional kitchen knife. Let's see how it turns out. Using an axe as the main design inspiration for something like a kitchen knife is a questionable design approach. But it seems obvious to me that there is a knife in the kitchen that's fairly similar to an axe, and that is the cleaver. Now, there's a lot of kinds of cleavers that you can make or that you can use in the kitchen. Some are super thin and light, like the Chinese cleaver, while others have a much thicker and stronger edge, more designed to cleave through bones and hard to chop items. I don't necessarily think that a ultra thin cleaver is the best option for this, but I also don't want to make something that's comically heavy. So my plan is to make something sort of in between. Not necessarily to be used as your primary chef's knife, but a knife that could definitely be useful if you have some medium to heavy chopping to do in the kitchen. One issue that I ran into right away when starting this project was that I didn't have any stock in my steel bag wide enough or close to wide enough to create this blade. Now, I want to make a blade that's close to 4 inches wide, not super long, probably 7 or 8 inches long. And so what I had to do is forge weld together some steel I had. Now, I had a really thick piece of something called ADCRV2, a really tough high carbon steel. I believe it's a Swedish steel and it's used for saw making. Anyways, one of the toughest steels I've ever used, and I matched that with some W2. Now, I have no idea if this is a good combination of steels. I've actually never combined it, but I know both of them individually are really tough with, in my opinion, and testing, ADCRV2 kind of taking the most abuse of any steel I've seen. So I think it'll be good, but I guess we'll find out in the end. At this point, I've got my billet forge welded together, and I've started to draw out the width, really focusing on drawing the width out. To me, that's the most important part to try to get done before getting it drawn out to any kind of length. Now, I'm really not going for a super long blade, so it kind of naturally happened. The length was achieved as I drew out the width. And at this point, I'm also starting to forge in a bevel across the whole piece. So that means that the spine section of the blade is a lot thicker than the edge. This is important to forge in so that I don't have to do too much stock removal, well, really any more stock removal than I already will have to do. Now, with my paddle of steel forged to thickness with a bevel going down the whole thing, it's not looking much like an axe, but that's okay. We'll make it look more like a cleaver axe here pretty soon. First, I need to get this thing normalized, which is what I've been doing. And normalizing is basically a reset of the steel. Now, forging causes a ton of chaos inside, and heating and cooling in the still air resets the steel. And with that done, I can transfer the design that I came up with onto my paddle and begin the process of cutting it out. Now, there's a couple changes I had to make to this design from the original axe. Now, the two things that I really loved on the original axe was there's like a cool curve going up the blade, and then those cutouts. Those are just super iconic and really eye-catching in my opinion. And they honestly wouldn't take away from the performance of the axe other than maybe taking away some weight, but ultimately it would still be really good at chopping stuff. And so I decided to keep those, and then I took away some of the curve of the edge, but it is still a pretty curvy edge, at least for the work that I do. The changes that I made is I took the widest point of the blade from being at the very front of the blade and moved it to the back or the heel of the blade. Now, on an axe, it's totally okay and probably good in some cases, like a battle axe, that the widest point is at the top or near the top. But on a kitchen knife, that wouldn't necessarily be the most functional design. Having the more width at the back of the blade, at the heel, is going to do a couple things. It's going to give your knuckles really great clearance off the cutting board. And aesthetically, it's just going to look a little bit better. I kind of realized I didn't necessarily have two great reasons, but I do know that it does aesthetically make the knife look better and give your knuckles really great clearance, which when you're using a knife that was designed thoughtfully, you definitely notice the difference. Now that I've got my profile shape cut out, did just a little bit of bevel grinding, not too much. I'm probably about 50 thousandths of an inch thick at the edge, which if you don't know thousandths of an inch and how thick that is, it's probably a little bit more than a quarter thickness. Maybe I'm wildly off there. If you're a thousandths of an inch thickness nerd, maybe you can correct me in the comments. But it's a good thickness to have before I quench and harden this blade. Because remember, I haven't quenched this blade yet. And that's why I can drill through it so easily like I am here. Now, I went through a lot of methods I could potentially do to create these cutouts. And in the end, I decided the best method would be to drill all the holes and then connect the dots. And I was pretty surprised at how fast and easy this was. I thought it would take a whole lot longer, but having the steel pretty darn soft from the normalizing cycle, it went really, really fast, really easy. Now, the original plan was to drill the holes, connect the dots with the Dremel, and then file down all those little pointy parts, all those little tabs that stick up. So with my cutouts done, grab my file, and realized it would take absolutely forever. Instead, I decided to annihilate one of my Dremel bits. And I'm thankful that I did. One of these bits cost like $13 or $14, so that was a price I was happy to pay to get these cutouts moved along and smoothed out really fast. Now obviously, I didn't want to leave them all rough and ugly from the Dremel, so I did use a file, but using the Dremel and then the file made the process that much easier. And with my cutouts done, the edges chamfered, or if you're across the pond, chamfered, I'm ready to quench this blade and give it a soul. Now, it's a really strange shaped blade, and I want to prepare for any chance of warping and, well, prevent any warping. So, some suggestions in the comments on a few of my previous videos were clamp your blade between two pieces of steel or aluminum, and I don't have any aluminum, so I opted for steel. Now, it looks like I pulled that out of the quench like way too early. I didn't. I just cut the footage. It was in there for probably 10 to 15 seconds, so definitely enough time for it to harden. Then I got it in between those pieces of angle iron to keep it from warping. And when I took it out of those pieces of steel, perfectly straight. No warps, no bends, and I was very happy. Brought it home, put it in the oven at 350 degrees Fahrenheit for two 2-hour cycles. So with the blade done, and the question in your mind of where the heck is the handle or the tang, I can answer that now. In the movies, in the props for the movies at least, those axes were not forged traditionally. They have very flat blades and then a very sudden socket. And so I don't obviously know exactly how they made them, but I'm making mine so that it looks similar, and the method I've decided to use is to forge down a round pipe into a square pipe, give it a taper, make it look good, kind of make it octagonal, and then weld it to the blade. I imagine they probably did something very similar if those movie axes were even made of steel at all, which I don't know. If you do know, I'd actually be really curious to hear, how did they make Gimli's axes in The Lord of the Rings? I know that the props were made at the Weta Workshop in New Zealand, but I don't know how they were made. So if you do know, I'd be very curious to hear that. Anyways, back to the socket. I'm just using a punch that's got a square cross section. It's tapered, and it gives me just enough support inside of my socket so that I can forge this circle down into this more square cross section. Now, I don't want to do any grinding on the socket. I want to leave it as forged. I want to leave that cool rough forged finish, rough forged look, so it looks like it was forged by the dwarves in the mountains, in their mountain forge workshops. The other goal of this project is to make something that looks like it could have come from the Lord of the Rings world, not from Matt Waters' America, Colorado workshop, but the Middle Earth workshop. Now, I don't make a lot of things like this, so we'll see how successful I am in the end. If it looks stupid or looks cool. So far, I'm pretty happy with how it looks. I couldn't quite... I was having a bit of like a dish kind of thing occurring in the middle, and I needed to forge down just the outsides, which essentially would push the center up just a bit so it's not the opposite. And I was able to do that by just clamping that extra piece of steel in the vise and knocking the corners down. Like that. And now comes the tricky part of cutting a slot that's centered and fitting and also curving the front so it matches that curve of the cutout, fitting my blade in, and then successfully welding the two together. Now, I'm not going to do anything like forge welding because the blade's obviously already heat treated. If I stuck it back in the forge at this point, I would ruin the heat treat and basically restart that whole process. I have no interest in doing that. So this is the method. I'm going to cut this slot, fit it up, and bring it over to the welding shop and MIG weld this socket to the blade. Now, things are looking pretty good at this point. I'm getting really excited, and I'm also realizing this looks a lot more like a goosewing axe, which is like a also really cool axe, but a finish style axe used in woodworking. So it's kind of like a combo of a real world axe, cleaver, and Gimli's axe combo. Anyways, back to the present. If you're going to weld high carbon or high alloy steel, I don't know as much about welding. So again, if I'm wrong, let me know in the comments. I'd love to learn. But from what I do know is you usually need to preheat those kinds of steels. So I hit the spine with the map gas torch, got it heated up to about blue, maybe 500-600 degrees on the spine right there. And then clamped everything up in the vise, made sure it was nice and straight, and just a little bit at a time. I didn't want to burn through the socket or my blade. Got these two welded together. Now, once all my welds were complete, I realized just how much cleanup I'd have to do. Well, I initially planned on not doing any kind of grinding on the socket. I unfortunately had to file away a little bit of that cool forged texture, but it was necessary so that I could clean up those MIG welds along the spine. That was something I obviously couldn't leave there. So ended up having to do a little bit on the front of the socket as well, but it still ended up looking pretty good. This was a pretty tight space. I actually ended up making that gap maybe just a little bit too tight.
You use it like that. It doesn't even need a handle. But I'm going to put a handle on. Don't worry.
Okay. Even without a handle attached, this is already extremely comfortable to hold. And I haven't tested it on any kind of food yet, but I think it would work pretty well even without the handle. Obviously, I'm going to make the handle, but it was kind of fun to see just how comfy it already is. And I think it's looking pretty sweet by this point. Well, filing in these super tight corners where the bolster meets the blade was definitely a challenge. It took a considerable amount of time. Though the work did pay off, you could see just a little bit of remnant of the weld by the time I was all done with it, but not enough that it really pulled away from the whole look of the blade. I think I blended it as good as I could have. One other nice part about this is with the cutouts and with forging the bevels in before I cut the profile shape out, I don't have a ton of grinding to do. I really actually don't want to grind up onto the, I'm going to call it pillars between the cutouts. It kind of looks like pillars, like maybe from the Mines of Moria or something. I want to leave those forged texture. I think that'll just aesthetically, it'll give the look and the vibe and the feel that I'm going for with this piece. So I'm really just going to grind the section of the blade that's solid down there at the bottom. Now to make this as functional as possible, I want to grind my bevels down to almost a zero grind. Now what that means, if you're unfamiliar with the term, is basically both sides of the bevel would come down and almost create a sharp edge without any sharpening, and both sides would be pretty flat. Now, I ended up doing just a slight convex just to give this some strength in chopping, but I did get the edge very close to being a zero grind. And the grinding didn't take a whole lot of time, used pretty rough grit, 36 grit belts, and was able to move on to getting the handle cut out. Now, typically, I like to choose really highly figured or exotic woods, but for this blade, I want all of the focus to be on the blade itself. I don't want to distract from that at all, so I just chose a piece of white oak. Now, white oak would make a pretty lousy axe handle. Hickory, in my opinion, is the undisputed and undefeated champ of axe and hammer handles. You can leave your comment of what you think is a better axe or hammer handle, but I don't think my mind will be changed. I think it's the best that you can get. But for a kitchen knife, or a kitchen cleaver, I should say, I think white oak would work perfectly fine. And there's oak mentioned in the Lord of the Rings and not hickory, so we went with oak this time. And getting the white oak fit up to the inside of the socket was pretty similar to fitting up an axe. I would tap it in a little bit, grind off where I could see marks left on the wood, and go back and forth until I got the fit up really nice and tight and as close as I could get the border where the wood meets the steel, as clean as I could get that.
Oh yeah. Only issue, that's a little tight. That's just a little too tight. I'm going to grind a little bit away.
Now, I haven't quite used this for any kind of kitchen tasks yet, but I will say that's really the only issue I have with it so far, is that I welded the socket on and made that gap just a little too tight. Now, I have pretty skinny hands and fingers, so for my hand, I got it to the point where it fits comfortably, but it might be a bit of a tight fit if you have big, fat dwarf fingers. Hopefully, like Lord of the Rings dwarf fingers, like that's a good thing in this scenario. It's not a diss. Okay, moving on. Keeping the bottom of the socket flat it just looked incomplete to me. So I decided to carve like a little scoop. And that little scoop turned out to be enough of an aesthetic flair that it looked really cool to me. So I think that I'm happy with that. I'm gonna move on to getting the handle fit up perfectly, and then do some ornamentation. Now, to get the blade prepped for whatever ornamentation I decide to do, I need to get the bevels hand sanded. Now, hand sanding really just changes the direction of the scratch lines on the blade. Off the grinder, those scratch lines go across the bevel, and this doesn't necessarily look great on high-end pieces. It's not a bad thing, and I think there's a time and place, and if you're making a knife that's just a workhorse, those scratch lines going across the blade are totally fine. But if you're making a more high-end or like a statement piece, then Again, it really depends on situation, but I'd say overall, getting those scratch lines to go with the bevel, with the blade, tends to look better. So that's what I'm doing on this piece. Now, since I don't have too much bevel to sand, this really didn't take all that much time. And I don't feel like I need to get a mirror polish on this piece because Gimli's Axe just doesn't have a mirror polish. That's not the vibe. So all I had to do was sand up to 400 grit and I was done.
So I've got some dwarven runes from Tolkien's dwarf language, and then some just basic like stuff I'll carve in all around it. And if you're wondering what the runes say, it says Chef Gimli. Chef Gimli on both sides.
This is definitely a point that I am very unfamiliar. Up to this point, I've been somewhat comfortable. I've kind of known what to do. I've done it before. But now I have never done this before, although I've wanted to. And so I went back to the old adage of keep it simple, stupid. And I'm a little worried it may be more stupid than simple, but we'll see, I guess.
Chef Gimli. I don't know if this is really cool or really dumb, but I did it.
That's what we call a no hesitation move.
Right.
Hopefully it was a good idea, but there's no turning back now, so I have to run with it. Now, Gimli's blade in the movies is this cool, dark gray, like worn, weathered look, and I definitely want to accomplish that. So I'm trying to etch it in some ferric chloride and see if that gives me the look I'm going for.
It's dark, but it's not like super dark. And what I want is super dark. So I'm going to hit it with some of this stuff, permablue. But instead of just putting it on cold, I'm going to heat it and then apply it. All this junk around.
I haven't used gun blue on a lot of projects, and so I don't quite know the best approach, but I decided to get some of the looser scale off after soaking it in the ferric chloride and then heat the piece up. Now, my Googling research told me that heating the steel up and then bluing it, as well as my gunsmith brother told me that heating it up and then bluing it will give you the best result, the darkest look. So that's what we're going for. Grabbed a little food torch and then, not quite sure the best way to apply it, took a rag and just started wiping it on. After these first few wipes, I wasn't happy with how it was looking, so I decided let's just soak this thing and see if that makes it any darker. So far, actually rather quickly, it made it a lot darker.
I don't actually know how you neutralize this stuff if you need to. I imagine I need to, though. So I'm going to just do some quick Googling and try to figure that out. Because then after this, it's just like a little bit of cleanup and assembling the handle, and we're good to go. What am I talking about?
Now, I didn't spend a ton of time, but Google did not tell me it needs to be neutralized, but I went ahead and sprayed it with Windex because the ammonia, at least in Windex that has ammonia, neutralizes ferric, so I thought, what the heck, it won't hurt it. Did that, took a Scotch-Brite, scrubbed off any excess oxides that formed, and then hit the whole thing with WD-40 to let that dark really set.
Apparently WD-40 helps like set the dark finish in, so
making the most of the time, I decided to go ahead and get the epoxy mixed up and the handle glued on after spraying the blade down with W40. Now, I was pretty careful not to let any of that get inside of the socket itself, as that would prevent the epoxy from bonding to the socket and the wood. One thing I learned here is that when there's no place for that pressure that's built up, when you fill that thing up with epoxy, when there's no place for that pressure to escape, it's incredibly hard to get the handle to go inside the socket. I got it about 99% of the way there, but I couldn't get that last little bit, and I was worried if I took the clamp off that the handle would fly away.
Oh, wait, is it coming out?
Thankfully, it was in there tight enough by this point that it didn't, and I was able to smash the handle in the rest of the way and then get the clamp back on and let the epoxy cure. Something of a last minute decision, and hopefully something I won't regret, I decided to add a pin to this handle just as one more way of securing the handle inside the socket.
It lined up. I was definitely a little worried
That
about
was
that.
a moment of me being relieved that the hole was actually pretty darn straight through and I wasn't off at all. Using a section of 1/8 inch brass rod, I got it cut so that it slightly protruded from either side, and then going back and forth, pinned over each side of that pin, thus giving me a mechanical bond as well as the epoxy. Now, instead of using anything like wood stain on this, I decided to torch the oak with the little torch that I've got. And once the torching was complete, I would then use a wire wheel to get all of the ash scraped off. Now, I thought this was going to result in a really dark finish. Usually on hickory it does. But for the oak, it actually came out like this really nice, deep, dark brown color, which I just wasn't expecting. So I was pleasantly surprised because that dark brown really matches the movie axe that Gimli carries. So I thought that was pretty cool. I was pleasantly surprised by that. Now the last step in this process to get this thing complete is almost cut your finger off slipping on the water stone. Not actually, don't do that. Just to get an edge on this thing. Now I don't think that using the belt grinder is the best option for this, as I don't want to slip and mess anything up, so I'm using my water stones. Now, if you don't have one of those fancy water stone holders over the sink, you can use a wooden table and some screws, like I am. Again, I don't know if that's the best thing to copy, but it works. I got this thing all the way up to a 6,000 grit stone. You gotta be really careful with these high grit stones. At least the ones that I use king stones. They're really soft when they get up to those high grits, so you gotta go real nice and gentle. And after the 6,000 grit, I load my leather strop up with some compound and strop away. Now the stropping is breaking that burr that I created, and the burr is just like a little wire of steel that forms on the edge from sharpening. Then you break that thing off and you've got a wicked sharp knife. I was pretty happy with how sharp and thin this edge was, but the question still remains, how tough is this thing? Does it perform like an axe and a kitchen knife? Cuts water bottles pretty good, but now it's time to put it through some real tests. To start, I want to see how it fares against one of my chef's knives. Now this is a knife that has some hollows ground into one side, so it's an asymmetric grind, which give you some pretty sweet food release, especially when cutting foods like potatoes, which are pretty sticky to the blade. It's a really fun to use knife. It's a really well balanced knife, really thin, really light, fast, sharp, all that stuff. Love to use it. So I'm curious to see how this holds up against that. It's not a completely fair test, and it's not a completely safe to eat potato either, but it's still a good test. And the first thing I'm noticing is that while the heel height is nice, it's a little high, maybe a little bit too high if you're going to use it just like a daily driver. But it is very sharp and it cuts very nice. And I suppose if it's the one knife you used a lot, you get used to it. In fact, I got kind of used to it after just a few minutes. And this rocking motion, well, it frankly rocked. And I was able to get some very thin, delicate slices on these potatoes. First chop that I've done with it, amazing. I mean, amazing. This thing chops like crazy. Now, I am an amateur chef, amateur home chef. Half the meals I make don't turn out great, but sometimes I make some good meals. And I really don't know when you'd use a cleaver in the kitchen, because I don't go that crazy in the kitchen, I guess. But I think this would work pretty good. Chopping into some oak, nothing. But I didn't want to stop there, so I decided to see How would the edge hold up if I chopped halfway through this board of white oak? It's not a super heavy knife, so this took a while.
Dude, absolutely no damage. It still push cuts right in the middle. Quite possibly my favorite part of this knife is just how cool it looks. How cool that profile is. Epic. Look at that. So cool.
Overall, I was just thrilled with the performance of this thing.
Orc helmet.
As a cleaver, like primarily used for chopping, this thing freaking rocks. The edge retention is crazy. So super pleased with that. As like a daily driver, probably won't replace your 8-inch chef's knife, but overall it's pretty sick. Now if you're interested in buying this piece, it's available for sale on my site. If you're interested in learning how to make knives yourself or connect with me and other smiths, check out my school community called Backyard Bladesmiths. Free to join right now. Thank you so much for watching. I'll see you guys in the next video.